Hi, my name is Navinasha and I'm from Group G. Today I'm going to perform task 1, which is a summary of Fourier transform. Let's start with the definition of Fourier transform. Fourier transform is a mathematical operation that converts time domain data in the FID into frequency domain data in the spectrum. The Fourier transform takes a time-based pattern, measures every possible cycle, and returns the overall cycle recipe, which means the amplitude, offset, and rotation speed for every cycle that was found. In a Fourier transform, a sinusoid is a specific back and forth pattern. It refers to sine and cos wave, and 99% of the time it refers to motion in one dimension. The Fourier transform finds the set of cycle speeds, amplitudes, and phases to match any time signal. For making a spike in time, when two cycles are on opposite sides of the circle, their combined position is zero. When every cycle has equal power and zero phase, we start a line and cancel afterwards. For moving the time spike, the the cycle ingredients should be similar to data, but the cycle must align at t is equals to 1. Phase shifts, phase shift, the starting angle are delayed in the cycle universe. For discovering the full transform, we need to loop through every frequency to get the full transform. So as you can see the first picture, to get the full transform, we need to use these equations to get the full transform. Then the Fourier transform takes up a signal and decomposes it into its constituent frequencies that make it up. The strength of signal can be measured at some specific time by measuring its amplitude. The Fourier transform enables us to discover and recover the original signals from the new signal, which is the sum of the amplitude. Inverse Fourier transform is used to transfer or bring us back from the frequency domain to the time domain. The three things that we need to consider to describe a signal is, first of all, is the frequency, the second thing is amplitude, and the lastly is phase shift. These three components can be encapsulated in a single mathematical formula. An infinite series of sinusoid is capable of constituting any continuous signal in the time domain precisely. In signal processing, sampling is defined by Wikipedia as the reduction of a continuous time signal to a discrete time signal. In order to understand modification of the algorithms known as a discrete Fourier transform, we have to understand how to sample a continuous signal beforehand. The quality of the signal is determined by the sampling rate. A finite series of sinusoids will manage to produce any sample signal of length in a time domain. In standard Fourier transform, we use a discrete case. We don't have a function, we have a data set, a set of points which we get by sampling the continuous signal. So, in conclusion, since the discrete Fourier transform is so simple, basic, and slow, we would rather use the fast Fourier instead. It is more suitable to be used in production environment compared to the discrete Fourier transform. So this is the second picture shows how to find the energy at a particular frequency. So spin your signal around a circle at that frequency and get the average a bunch of points along that path. So these are the summary of Fourier transform that I got from task 1. Thank you.
Hi, my name is Wong Mei Bei. Now I want to explain about the question of task 2 for Fourier transform. This is question A. For question A, can use this formula to solve the question. This formula can get from the table. So W0 is equal to A. Then, using the formula of time shifting to get the answer, Fw is equal to this equation. Then, take the A out because formula of time shifting is equal to T minus T0 only. So, T0 is equal to pi per 3a. W is equal to minus A, so replace the W with minus A. W is equal to A, so replace the W with A. Last, we will get this answer. This is question B. We can use this formula to solve the question. 2 is a constant factor value, so take the 2 out and integrate the delta t minus 1 exponent negative jwt only. Can see that this is an integral transformation of ft from time domain to frequency domain. Integrate exponent negative jwt will get exponent negative jwt per negative jw. Insert the infinity and 1 to the equation. Infinity will get the answer of 0. At the end, we will get this answer, and don't forget the value of 2 that we take out before. This is question C. Delta t is equal to 1 that we can get from the table. Using the formula of scaling to solve this question. Delta 3t. A is equal to 3, so we'll get 1 per 3 multiplied with delta t that is equal to 1. Because there is no W, so just ignore the W per A. Delta 2t also do like delta 3t. Delta bar 2t is differentiation, so use the formula of time differentiation. This is the formula of time differentiation. Fw is equal to F delta 2t that is equal to 1 per 2 that we get before using formula scaling. So we'll get Jw per 2. So delta 3t, that's 1 per 3, is minus with delta bar 2t that is Jw per 2. Hence, we will get this answer. This is question D. Using this formula to solve the question. Take the 3 out first because it's a constant factor. Do the integration for exponent negative jwt and we'll get exponent negative jwt per negative jw. And negative jw is take out. Exponent jw2 minus exponent negative jw2 per 2j is the formula of sin w0 t. That's why we will get the sin 2w. At the end, we will get this answer. This is question E. When see question like this, first, what you need to do is assume that u is equal to 2t minus 3. Do the differentiation, we'll get 2. Then, find the t first because we'll use letter. So, t is equal to u plus 3 per 2. 2t minus 3 is equal to u. T is equal to u per 2 plus 3 per 2. dt is equal to du per 2. Take the 1 per 2 out. Exponent negative 3 per 2 jw will also take out. This will equal to sw per 2. This is our last answer. This is question F. The step to do this question is same with question E. Also assume that u is equal to 4t minus 8. Do the differentiation, we'll get 4. T is equal to u plus 8 over 4. 4t minus 8 is equal to u. T is equal to u per 4 plus e per 4, that will get 2. Take 1 per 4 out and exponent negative jw2 out. This will equal to SW over 4. Hence, this is the answer for this question. That's all for question of task 2. Thank you.
Hi, my name is Kang Chauna.
Now, I would like to present about task 3, inverse Fourier transform. First, function. What is the function of inverse Fourier transform? Inverse Fourier transform is used to recover the function in time domain from its frequency domain. The next equation. What is the equation that we use to find the inverse Fourier transform? This is the equation that we use to find the inverse Fourier transform. 1 per 2 pi integrate limit negative infinity to infinity f omega exponent j omega t d omega equal to ft. Now let's go to question 1. The question given is f omega equal to 100 per j omega that multiple with j omega plus 10. First we change omega into s. We get fs equal to 100 divided by s multiple with s plus 10. And we separate it into the partial fraction form. We find the value of a by using the value of s equal to 0, then we will get a equal to 10. We find the value of b by using the value of s equal to negative 10. Get the value of s equal to negative 10. So we fill in the answer we get for value a and b, and we get the final answer equal to 5 SGNT minus 10 exponent negative 10 TUT. Let's go to the question 2. As question 1, first, we change the omega into s and we get 10s divided by negative s plus 2, 3 by s. Same as question 1, we separate the answer into the partial fraction form. Then we found the value of a by using the value of s equal to 2. Then we get the value of a equal to 4. Then we find the value of b by using s equal to negative 3. And we find the value of b is equal to negative 6. So the final answer we convert into time domain. So we get the final answer is 4 exponent 2t u negative t minus 6 exponent negative 3t ut. And now let's go to question 3. The question given is h omega equal to 60 divided by negative omega square plus j 40 omega plus 1300. First, we convert the denominator into j omega plus 20 square plus 900. This is because the denominator must is the square of numerator. 900 is the square of 30. So 60 is become 2 multiplied by 30, and we got 60 equal to 2 multiplied by 30, and 900 is become 30 squared. So we get the final answer is 2 exponent negative 20t sin 30 3 ut. Let's go to question 4. The equation is given by omega equal delta per j omega plus 1 j omega plus 2. First, we convert the equation into the form of equation inverse Fourier transform. The delta W is multiplied with 2 pi so that the answer is equal to the equation that given in the beginning. So we find the answer by using the equation of inverse Fourier transform. Find the value of a and b by using the partial fraction, and we get a is equal to 1 and b is equal to -1. We get the final answer 1 per 2 pi multiplied with exponent -t minus exponent -2t multiplied with ut.
Assalamualaikum, my name is Amira Zakira binti Muhammad Hairi and I am from Lab Group G. I am now presenting task 4 for Fourier transform. So let's begin with the poster. This is the poster, and as we know that certain transformations tend to be complicated to handle or solve. Therefore, there are several properties that can help us to find transform of complicated functions, such as linearity, time scaling, and time shifting. For linearity, where A1 and A2 are constant, this property simply states that the Fourier transform of a linear combination of function is the same as the linear combination of the transform of the individual functions. This means that if a function is multiplied by a constant, the transform is multiplied by the same constant. So A1 and A2 must be the same. For example, as you can see, this is the function of the Fourier transform, and we need to multiply it with the same constant using the general information. General equation. And when we solve it, we can finally get the final answer. So using the linear property will make us easy to find the final answer for the functions. For time scaling, where a is constant, the equation shows that time expansion corresponds to frequency compression. This is simply means that the time scaling property is when the time expansion in a function or equation corresponds to frequency compression or vice versa. Or in other words, if a function is expanded in time by quantity, the Fourier transform is compressed in frequency by the exact same amount. So this is the general equation. As we can see that, for example, this one. So ft, which means this one. So we can use time scaling to solve these complicated functions. So by using time scaling, we can get the final answer, just like the linearity. For last but not least, the time shifting. So time shifting is generally the property means the shift in time correspond to a phase rotation in the frequency domain. Or in other words, the function in one domain corresponds to a multiplication by a complex exponential function from another domain. So for example, this complicated function, we can use time shifting to get the final answer to solve it, which means time shifting is a way to solve the equation in short period of time it's not that short, but it is easier for us to use time shifting to solve the equations, so we can get the final answer. So that's all for me. Basically, the properties, these three properties are some ways to solve complicated functions easily. That is my opinion, and it is much helpful for us as a student, because a complicated function can sometimes, you know, it's stressful. Okay, so with linearity, with time scaling, time shifting, these properties can actually help us to solve the complicated functions easily by using the general equations. So that's all from me. Thank you.